Hello? Hey, let's have a look of LAB5. Today, just as usual, we just have a look of the lab, and I will try my best to help you to do your lab. Before we have a look of the lab, maybe we should talk about some knowledge before, it, such as the OFDM. Do you know what is that? And the coding and the version of AO 2.11. I think you have already learned what is that on the lecture. So let's have a look of it. The most important thing is MCS. Do you have any idea what is MCS? We have mentioned it in the lecture. So if you don't know, just maybe you should have a review of the lecture. So before you do this lab, make sure you have very deep understanding of it. So it will help you a lot and save you a lot of time. The basic concept is pretty simple. Let us have a look. Uh, Here is a link. I find it's very useful for us. Let me click it. Yeah, here is a table. So why should we need this kind of table, and how should we use that? Let's have a look of the left corner. It is MCS index. And so HT, VHT, and HE, what does this stuff stand for? HT, which stand for the high throughput, and VHT is very high throughput, and HE is for the high efficiency. So do you know what is the version for the high throughput? The version of high throughput is AO 2.11N, and the very high throughput is AO 2.11AC, and the high efficiency is AO 2.11AX. So just keep in mind, if you have different version of AO 2.11 protocol, so it may use different index in this table. So why should we use this table? Because we want to have better understanding for the MCS. So when we load some stuff like this, we can see that there is a file type is AO2.11G, right? So we can have a look of the table here. Like this one is 6. Then we can have a look of double check of the speed, right? Something like this. So that's the reason why we need to use this table. So we can like according to the MCS index and the spatial string and the modulation and coding stuff, and we can calculate the speed of the our connection. Okay, so let's see how can we use that. At first, we need to have a look of the MCS index. Let me open another file. Maybe here. Sorry. Let's have a look at this one. You can see here. So how can we find if we cannot see this row? So can we calculate the rates with that table? Let's have a look at it. The table is here. So if we know the protocol is L2.11n, so we should have a look up here. And this part, because this it says that prior 11AX, so 11n is prior to this version. So we have a look at this part. And the MCS index, which means we need to have a look of the index of 15 here. And we also need to have a check of the bandwidth, which is here, is 20 MHz. So we need to have a look of this column. And how about the GI? What is GI stands for? It's graph interval. So we have already learned this in our lecture, right? This one is 0.4 microseconds, which means 400 nanoseconds for the graph interval. And this one is 800 nanosecond interval. So how can we determine this? We can have a check of the short GI is true, which means we use the short GI, and which means this one, 400 nanoseconds GI. Then we can find the speed should be this one, 144.4. And yes, you can see the data rate. Actually, it is 144.4 megabyte per second. So that's how we use the table to calculate the bandwidth. So do you have any question related to that? You may also need to know what is OFDM. Which is orthogonal frequency division multiplexing. Okay. So if you don't have any question, let's just have a very quick review of them. The first one, what is HD, VHD, HE? HT stands for high throughput, and VHD is very high throughput, and this one is high efficiency. And they represent different version of AO2.11 protocol. And this one represent the AO2.11n. This one represent the AO2.11ac. And this one is AO2.11ax. Did anyone turn on his microphone? Let me turn off. Sorry. Okay. And the spatial string, what is that? So basically, we will have like 4 spatial strings, and the cutting edge protocol is maybe after the AO2.11ac, we will have 8 spatial streams, but most of Wi-Fi for now have only 4. And the modulation, we have learned a lot of kind of modulation here, like 256 cram or something like that. So basically, the idea is the more complex the modulation is, the higher data rate we have. But the complex modulation, which means we are required like better condition, such as we require less interference or something like that. So we can use complex modulation. And the coding, I think this one is related to the calculation, right? we always need to calculate about the coding rate or something like that. So what does this stand for? It's just an indication of how much of the data string is actually being used to transmit usable data. So which means the efficiency, for example, this one, which means about 83.3% of efficiency. So it's all related to the data speed. And the OFDM, I'm not going to tell you what is OFDM again, because we have a very clear view of it in the lecture. And the GI, growth interval. So it's basically a very short pause between packet transmission. So maybe I should click this link because I put a video here. Yeah, but we are not going to have a look of this video because it just repeats what is OFDM. I just want to show you what is GI. So the GI interval between them, you should know what is GI in this graph. Basically, it's just the distance from the pink line to the blue line, like between their peak. So that is the interval. So we always use 400 or 800 nanoseconds as our growth interval. And we also have a reference link. Then you can have a look of them, of all of these concepts by yourself after the class. And I think that's all we should know before we go to the lab. So if you have any question, just feel free to type it. So there are 3 tasks in our LAB5. We have 3 things to do. Let's have a look of the first one. The first one is pretty easy. The first part is data collection. I think just quite similar as previous labs. You can see just, let me see, what is the key point? Just start collection, you just move away, right? And then bring it back slowly. So you may need to have at least 1 minute for the whole process and make sure you have enough packets to analyze. And the second part is about the report. Just analyze the RSS, MCS, and the data rates from the trace file, and just describe how the distance affect this kind of stuff. And you may need to plot some graphs and write a commentary. Does that make sense? So let's have a look at some sample of it. So how should you analyze the RSS? The RSS is pretty simple. We have done lots of times, just signal strings here. Or you can find it inside the package. And the MCS, this one we never tried it before. You can find it in the AO 2.1 radio information here. You can see the MCS index is 15. Can you see that? Okay. If you can see the MCS, then we can have a look of other packets. For example, we go to the middle side and have double check. It's still 15. Let us make it as a column. Yeah. So we can have a very quick look. You can see some of the packets will switch the index. This one switch to 13. And and 7, 4. So you can see different packets may have different MCS index, which means our network interface have detected we are using a different MCS index, and thus we will have a different data rate for some reasons. So you need to analyze why we are switching the MCS index. Okay. This one should be pretty simple. And let's go to the next one. The second one, you can see it's almost the same, I would say. It's also have two parts. The first one is data collection again. All we need to do is bring an obstacle between them, such as a sofa. But this time you are not required to move around. Just put your hotspot at a place and maybe insert an obstacle when you start the collection. Okay, you can see slowly. Just insert the obstacle slowly and remove it again. Does that make sense? So at first you don't have anything between your sender and receiver. And then you bring an obstacle. You just insert the obstacle between them. Maybe and wait for like, I'd say maybe 10 seconds and remove it slowly. And you also get a CSV file. Maybe this process will take like 1 or 2 minutes. Should be enough. And then just perform the analyze, just like the task 1, but this time we just analyze how the obstacle affects the data. Okay, you still have a look of the ISS and MCS. So what does this mean is you may need to plot a graph of how MCS fluctuates, and maybe you are need to require to tell us when did you insert this obstacle? Like you have insert the obstacle at 75 seconds, and you move the obstacles away, maybe from 100 seconds. You need to tell us and analyze how this affects your MCS and ISS. And you can also you are also need to analyze the data rate. The data rate is here. Okay. And the last task, I think this one is the hardest one because for the data collection, it's not pretty easy to do this one. You can see we are not only require a phone and a laptop, we also require a smart TV and maybe as well as an oven or something like that, which use the 2.4 gigahertz frequencies. You may require a smart TV or a microwave oven. For some students like me, I don't have them, so I may have some trouble. So last year, I went to my friend's home and borrowed his microwave and do this lab. But because we are in COVID situation, so if you are not be able to do this for some reasons, just maybe send us an email or post it on the forum, and we can help you. Okay. So if you cannot do this task, maybe we can discuss later. So if you are able to collect this data, it should be not pretty hard because just start the collection and turn on the TV and play a video. You can, if you are using a microwave, you just turn on the microwave and have a look. So if you don't have one of them, just don't worry and describe it on the report and you will be fine. And that's all. And analyze is about the microwave operation, okay? So you will need require to describe what happened during this time. So my suggest is maybe you need to make some notes when you collect the data. For example, I start the collection and I made a note. Maybe I turn on my smart TV at maybe 15 seconds. So I know what happened at this 15 seconds and I will have a look of it. And I will also record the time I turn on the microwave oven. So I can have a look of the data set at that specific time. Here is a question. Are we moving away and towards the laptop for task 3 as well? No, I don't think so. We are not required to moving around in task 2 and task 3. You can see the difference between these 3 tasks is requiring us to analyze the different situation. Like for the first task, we are going to compare different distance affects the MCS and data rate, right? And the second one, we are going to see how about the obstacles affect the data rate. And the third one, we just have a look of other applicants such as microwave will affect the data rate. Another question is, for task 2, could I use the data from LAB4? Yes, sure, you can. You can use the data if you have already got it. Should we filter packets according to ID like before? Yes, we are required to do this. So for the CSV file, it's already filtered. Does the smart TV need to use my phone as access point? Yes. So you can see a sentence here. Turn on a smart TV and watch a video from the internet, right? So they should be in the same internet, which means the TV should also connect to your connect to your hotspot. So we want you to connect the smart TV with the same hotspot as your computer do. For the NS index, will that data show up with netmon data as well? Because when I open my previous lab data, it doesn't show the data like the one you showed. Yes, you may have this question. So let's have a look of here. For the previous lab, we have released the mark, so you can kindly have a check of it. Previous one is lab 4, isn't it? So you can have a look of your result of lab 4. So if you have any question or doubt for your marking stuff, then you can contact us. Here are some normal question. So some students may find it hard to capture this kind of package. For example, myself, I collect the data with the network monitor, but it is not working. So I borrow my friend's Mac and it is working, but I'm not sure what is the reason. Maybe some adapter does not support this. So I have provided the sample in case you have tried lots of method and still cannot capture any packets. And so do not be panic if you fail to capture the packets. Even you try a lot of different computer or different network interface. So I will provide you a sample. Let me find the link. I put the link here at the GitHub. Yeah, it's here. You can see I put the link here. Maybe I should post it on the forum, so then you can use it. So in case you cannot capture any package we want, then you can use this package that I provided to you. But I strongly recommend you to try by yourself at first. So do not use my provided files as in your report if you be able to capture the packet by yourself. And I also write down the comment about this stuff so you can read it if you need. Basically describing what have I done in this file. And you can also have a try of it to analyze the packet. Yeah. So we can know that there are lots of students may have some trouble on like capturing the MCS data. So in here I provide a sample data. So and now maybe you should try by yourself and to capture if you can capture the correct packet we want. But in case you cannot capture the packet, you can use mine and write your report, and that will be fine. But you need to tell us what have you tried and why. You just tell us the reason why you cannot capture the packet. Okay, tell us your effort instead of just directly using my packet. And some student may find the data rate doesn't change at all. And this might because of the distance is too close and the data quality is too good. So for example, you have tried two different distance such as 0.5 meters and 1 meter, and they remain the same data rate. That is because the data quality is too good. Maybe you should try like larger distance. For example, maybe 15 meters compared to 2 meters. And you can try the outdoor because we will have more space for you. For this lab, I think the hardest thing is the data collection. So you may suffer loss from the data collection process. So if you have any trouble or you got any solution or any new found, you can just feel free to post it on the forum and help us to figure out what is the reason we cannot collect the package we want. And yeah, I will post the link here of the sample data set. Here. So try now if you can download the data set in case you need to use it. So if you are using this data set, you are required to like tell us in the report. And I think that's all I have for today. If you have any further questions, just feel free to attend the future labs. It will be the same link as this one. And the timetable is here. Yeah. So just feel free to join any tutorial you want and ask question. So I strongly recommend you to finish this lab before the Thursday, since you can attend the lab and ask your question. Because we may have a lot of trouble on capturing the data or like analyzing or other stuff. And that's all I have. So if you have any question, just feel free to stay here. I will stay till the end. But if you do not have any question, just feel free to leave. And we will see you next week. Oh yeah, and maybe we should also talk about the project we have. So if you have any question or doubt of it, just feel free to send a message or tell me so I can prepare for that. Maybe for next week or another time. I think I missed some details at the beginning of the lab. There are no MCS packets in lab 4. Yeah, I think you didn't miss anything because we didn't talk about how to collect the MCS data. It's just here, just inside the packet. But if you found your packet does not have the MCS data, the I think the reason is complicated. So I cannot tell the useful solution to you. Maybe you need to figure out by yourself. But if you cannot figure out this question, maybe you can use my dataset to do this lab. Do we have any requirements of number of capture packets in data collection part? We don't have any requirements of the number of packets. Just make sure you have enough packets to plot the graph. For example, if you only have like 20 packets and you plot the graph and tell us this is what I got, maybe we will consider this one is not enough. So I suggest you have at least 100 packets, valid packets, at least. Yeah, and because in the report, we just something like analyze just the similar stuff as we done in previous lab. We just plot the graph and write down a commentary for each task. There are only data rates in lab 4. Maybe you can do it again and see if you can get it MCS. So don't worry too much if you cannot get it. So just try your best to fix this problem. But if you still cannot get it, just use my dataset. I have already sent the link into the chat. And you can also find it on my GitHub here. Sorry, it's here. This one. Yeah, and also if you have any idea about the program, just feel free to discuss with me. Okay, see you guys next week.